Are we really saying that the human species, after all this evolutionary fine-tuning, is suddenly producing too much of this one molecule that is now killing us? Here were two large randomized control trials designed to prove the diet heart hypothesis, and they actually refuted it. That is, by any measure, a bombshell. The American Heart Association is telling us to limit saturated fat to less than 6% of our daily calories. Meanwhile, the Tokelauans are getting nearly 10 times that amount, chain smoking daily, and they're still not having heart attacks. Trans fats in particular became one of the largest insults to human health in history. My name is Dr. Ravi Kumar. I'm a neurosurgeon in search of the causes of human illness and the solutions that help us heal and thrive. I want you to join me on a journey of discovery as I turn over every stone in search of the roots of disease and the mysteries of our resilience. The human body is a mysterious and miraculous machine with an amazing ability to self-heal. Let us question everything and discover our true potentials. Welcome to the Dr. Kumar Discovery. Welcome to the Dr. Kumar Discovery Podcast. I'm Dr. Ravi Kumar, board-certified neurosurgeon, and in this podcast, I aim to question medical dogma, break down bias, and bring clarity to complex health topics. I want to question everything. This is something I pursued in my own life, and it's something I want to share with you because I believe knowledge is power, and when it comes to your health, being empowered with the right information can help you make better decisions, just like it does for me. Now, just a quick disclaimer. I'm a medical doctor, but I'm not your doctor. This podcast is for informational purposes only. It's not intended to treat, diagnose, or manage any medical condition. What I share with you here is meant to help you think more clearly, ask better questions, and work more effectively with your own healthcare provider. This is the very first full episode of the Dr. Kumar Discovery Podcast, and it kicks off a multi-part series on a topic that's huge, complex, and deeply relevant to all of us: cardiovascular disease. Cardiovascular disease is woven into so many of our lives. Maybe you've had a heart attack or a stroke, or maybe someone close to you has, or maybe your doctor's told you your cholesterol is high and you need to start medication. No matter how it shows up, cardiovascular disease touches us all. And with that kind of reach, I figured, what better place to start? The World Health Organization reports that 20.5 million deaths were attributed to cardiovascular disease in 2021 alone. That's about a third of all deaths worldwide. It's completely staggering. They also state that 3.8 million of those cardiovascular deaths are linked to high LDL cholesterol. Now, when I hear something like that from the largest medical organization in the world, that a single molecule, a lipoprotein that our bodies have been producing for millions of years, is the primary reason for millions of deaths annually, I pause. It sounds reductionist and frankly oversimplistic. Are we really saying that the human species, after all this evolutionary fine-tuning, is suddenly producing too much of this one molecule that is now killing us? Because if that's the belief, then the next logical step becomes create drugs to suppress this natural molecule, to squash a fundamental part of our biochemistry in order to avoid death, which is exactly what has happened. When I lay out that logic, it just doesn't sit right. It feels incomplete and shallow, like something very important has been overlooked. Now, I'm not saying that the mainstream view is just flat out wrong, because that's not what I believe. What I am saying is that there's got to be more to the story. Approaching a problem this complex in such a reductionist and black and white way, that's how we miss things. That's how we set ourselves up for failure. That's how we end up mopping the floor rather than just pulling the plug out of the drain. And I think that's exactly what's happened with cardiovascular disease over the last 75 years. So let's start at the beginning. Let's talk about what cholesterol actually is. Cholesterol is a small, fat-soluble molecule that is absolutely essential to life. Without it, animals, including us, simply cannot survive. And I don't just mean humans. Every animal on Earth, dogs, cats, mice, salamanders, fish, you name it, they all make cholesterol. Every single one of their cells produces it, and every single one of those cells depends on it. Why? Because cholesterol is what gives structure and strength to the membranes that surround each of our cells. These membranes, called plasma membranes, act as the walls and the gates of our cells. They protect the internal environment and allow the cell to interact with the world around it. They let nutrients in, keep harmful things out, and allow the cell to communicate and work in harmony with the other cells around it. But here's the key. In animals, the membranes have to be flexible. Animals move. We stretch, bend, twist, and adapt, and so do our cells. Cholesterol is what makes that flexibility possible. Without it, the membrane becomes too rigid or worse, too fragile. The contents of the cell would leak out and the entire structure would just fall apart. In addition, cholesterol is also a building block for steroid hormones like estrogen, testosterone, and progesterone. It's needed to make bile acids, which help you digest fats and absorb fat-soluble vitamins in your small intestine. And it's also a crucial precursor for vitamin D synthesis, which influences everything from bone health to immune function. In short, cholesterol isn't just important, it's foundational. Without it, the most basic functions of life fall apart. So the next foundational question is, how do we actually measure cholesterol? Well, one key thing to understand is that cholesterol doesn't just float around freely in your bloodstream. It can't. Cholesterol is fat soluble, but your blood and most of the fluid in your body is water-based. Oil and water don't mix. So in order to transport cholesterol through the body, it needs to be packaged. It has to be bundled up inside little globules of fat and protein with an outer shell that's water-friendly. These packages are called lipoproteins. You've probably heard the names LDL, HDL, maybe even VLDL. These are all types of lipoproteins, and they act like delivery trucks, carrying cholesterol and other fat-based molecules through the bloodstream. So when you get your cholesterol numbers back from a lab, you'll typically see a few values. Total cholesterol is the sum total of all the cholesterol in your bloodstream. LDL cholesterol, often labeled bad cholesterol, stands for low-density lipoprotein, and it's the main carrier that moves cholesterol from the liver out to the rest of the body. HDL cholesterol, often called the good cholesterol, stands for high-density lipoprotein, and it does the reverse. It picks up excess cholesterol from the body and carries it back to the liver for recycling or disposal. Now, it's important to note that every cell in your body needs cholesterol, and while your cells can make their own, most of the cholesterol in your body is produced in the liver and shipped out via these LDL particles. HDL does the cleanup, bringing some of it back to the liver. This back and forth helps regulate how much cholesterol is circulating at any given time. There's one fascinating exception to all of this: the brain. Your brain doesn't rely on this system. It doesn't share cholesterol with the rest of the body. Instead, it makes all of its own cholesterol right there in the brain itself, mainly in these supportive cells called astrocytes. And that's important because later on we'll talk about what happens when you suppress cholesterol production. If your brain can't import it and you shut down its ability to make it internally, that has major consequences. We'll get to that later in a later episode, so tuck that one away for now. The final major number you'll typically see on your cholesterol panel is something called triglycerides. Triglycerides are basically a form of stored energy. They're made up of 3 fatty acids attached to a glycerol backbone. That's where the tri in triglycerides comes from. These molecules are your body's way of packaging fat for transport and energy use. And here's something super interesting. Your body doesn't just get triglycerides from fat in your diet. It also makes them, especially from sugar. When you eat carbohydrates, your body breaks them down into simple sugar molecules. If you don't use that sugar right away for energy, your body strings those carbons together to build fatty acids. Then it attaches them to a glycerol molecule, and voila, you've got a triglyceride. These triglycerides can then be bundled up, attached to proteins, and sent through the bloodstream to be stored or used for fuel. So when you look at your blood work, your triglyceride level is essentially a snapshot of how much circulating fat-based energy is floating around in your blood. And for most people, the primary driver of high triglycerides isn't dietary fat, it's carbohydrate intake, especially sugar and refined starches. Okay, so we've talked about how important cardiovascular disease is. And we've talked about what cholesterol is and why it matters and how we measure it. Now, the next question is, and it's the reason we're here, it's to ask this question: how did we get to this point where major health organizations like the American Heart Association and the FDA have concluded that we should decrease saturated fat intake because it increases LDL cholesterol and causes heart disease? Because that's the prevailing belief today. If you eat saturated fat, your LDL goes up. And the higher your LDL, the higher your risk of cardiovascular disease. Now, right up front, I'm not saying this is totally wrong, but I am saying it feels a bit too simple, and it's certainly not the whole story. To understand how we arrived at this idea that saturated fat and LDL are villains, we have to go back to the early 20th century. Around 1910, a German pathologist was dissecting human cadavers. What he found was striking: high levels of cholesterol inside atherosclerotic lesions of the aorta. That's the main artery that carries blood from your heart to the rest of your body. He found these diseased, hardened sections of the arterial wall, what we now recognize as atherosclerosis, and when he examined them, they were full of cholesterol. Now, at that point, we already knew cholesterol was a compound found only in animals, so the logic followed. If diseased arteries are full of cholesterol, then maybe eating too much cholesterol causes it to build up in arteries. That kind of connect the dots reasoning made sense. It was intuitive. And honestly, for the time, it wasn't an unreasonable conclusion. Later on, a Russian pathologist decided to take this a step further. He fed rabbits a diet very high in cholesterol. Now keep in mind, rabbits are obligate herbivores. They don't naturally consume animal products. But in this experiment, they were fed large amounts of animal-based cholesterol. And the result? When he dissected those rabbits, he found the same thing. Their arteries were riddled with atherosclerosis. Another piece of evidence was added to this theory that was being built. First, we see cholesterol in diseased human arteries. Then we feed cholesterol to rabbits, and they develop a similar arterial disease. To many, that was the second nail in the coffin. The cholesterol theory of heart disease was starting to take shape. So as this cholesterol theory was beginning to take root, a major shift was happening across the United States. Towards the middle of the 20th century, America was facing an insidious epidemic of cardiovascular disease. Men in their primes of their lives, middle-aged, healthy-looking, high-functioning men were dropping dead, often without warning. This wasn't something the country had seen before, and it sparked real concern. Here we had a disease stealing the lives of seemingly strong, capable men. And at the beginning of the 20th century, cardiovascular disease wasn't even the leading cause of death. It ranked well behind infectious diseases like tuberculosis. But by the middle of the century, that had changed. Cardiovascular disease had become the #1 killer. And then in 1955, something happened that brought national attention to the issue. President Dwight Eisenhower, while in office, suffered a massive heart attack. He was hospitalized for weeks. He survived, but that single event served as a turning point. Public awareness of heart disease exploded, and cardiovascular health became a national concern. And from that point on, the medical community became laser focused on understanding and preventing this new epidemic. Around this time, during the 1950s, a scientist named Ancel Keys entered the scene. Keys had traveled to the Mediterranean after World War II and noticed something very interesting. People in that region seemed to have lower rates of cardiovascular disease, and they also ate less total fat and less saturated fat than Americans. That observation stuck with him as meaningful. And as a researcher, he decided to study it further. So he began conducting controlled feeding studies. These were done in institutional settings, meaning the participants couldn't access outside food. Keys could feed them a precisely measured diet and observe the effects. And what he found was consistent and reproducible. Feeding people saturated fat like butter or lard raised their blood cholesterol levels. Feeding them polyunsaturated fat like vegetable oils lowered their cholesterol levels. This observed effect is consistently reproducible to this day. If you eat a high saturated fat diet, your total and LDL cholesterol levels will rise. If you replace those fats with polyunsaturated fats, your cholesterol levels will drop. That part really isn't debated anymore. It's biochemically well understood. What is debated, and this is crucial, is whether that rise in cholesterol from eating saturated fat actually causes cardiovascular disease. And that's where Ancel Keys became a central figure. Because of the growing concern around heart disease at the time, his work drew a lot of attention. Keys wanted to expand on his findings, and he found a source of data that could help. It was data from the Food and Agricultural Organization of the United Nations, which had compiled dietary surveys and cardiovascular disease mortality rates from 22 countries in the early 1950s. So Keys took that data, but instead of analyzing all 22 countries, he just selected 6. He then plotted each country's fat consumption against their heart disease mortality rates. The countries he chose were the United States, Canada, England, Wales, Italy, and Japan. And when he graphed them out, sure enough, a clean linear trend. Higher fat consumption correlated with higher heart disease rates. At the time, this paper made a big impact. It looked like powerful evidence. Lower fat, lower disease. Higher fat, higher disease. Case closed, right? Well, not quite. Not long after that, other researchers stepped in and challenged Keys' analysis. They pointed out that he had access to data from 22 countries, not just 6, and accused him of cherry-picking the ones that fit his hypothesis. They took all 22 countries and plotted fat intake against heart disease mortality, and the strong correlation that Keys had shown basically disappeared. So now there was a debate. Did dietary fat really cause heart disease? Or was this new theory, a link between fat and heart disease, built on cherry-picked data? So after criticism of his early work, Ancel Keys decided to take a different approach. Rather than relying on retrospective data, which is looking backwards at who died and what they ate, he wanted to collect prospective data, meaning he would follow people over time, observe their eating habits, and then see who develops heart disease or who died. That's how the 7-country study was born. It's one of the most well-known studies in the history of the diet heart hypothesis. Keys selected 7 countries to include: the United States, Finland, Netherlands, Italy, Greece, Yugoslavia, and Japan. He said he chose these countries because they were willing to collaborate and had a wide range of dietary patterns, enough variation to allow for some meaningful comparison. But it's also worth noting what he left out. Countries like France, Germany, Switzerland, and several of the Scandinavian countries, which are known to have diets high in saturated fat but low in heart disease, these were completely excluded. Keys looked at each nation's total fat and saturated fat consumption and compared that with their rates of cardiovascular disease and mortality. And again, he found a positive linear association. The more saturated fat a population consumed, the higher their rates of heart disease. The less they consumed, the lower their rates of heart disease. This was a major moment. It gave the appearance of strong support for the idea that saturated fats caused heart disease. The study received widespread attention. Ancel Keys became famous and ended up on the cover of Time magazine. He became a central figure in the movement to change how Americans and eventually much of the world thought about fat and heart disease. Eventually, the momentum behind this idea, the link between saturated fat, cholesterol, and heart disease, led to official recommendations. In 1961, the American Heart Association released its first major dietary guidelines. Eat less fat, especially saturated fat. Over time, those guidelines evolved into what we still hear today. The AHA recommends less than 6% of your daily calories come from saturated fat. And in 1977, the US government followed suit. The newly released dietary guidelines advised Americans to limit their total fat intake to under 10% of daily calories. These recommendations didn't just reshape American diets, they reshaped the whole world. Hey guys, I hope you're enjoying this episode so far. I want to ask you for a quick favor. If you're finding this valuable and you believe like I do in cutting through bias and getting to the real truth about health, then please help me spread the word. Just take a second to like, subscribe, and leave a comment. And if you can, share this episode with someone you think needs to hear it. The more engagement there is, the more the algorithms will push us out and the more people we can reach. And again, thanks so much for joining me on this journey of discovery. The 7-country study helped popularize the diet heart hypothesis. And that idea quickly became accepted dogma in nutritional science and public health. The core hypothesis of this was more saturated fat leads to higher cholesterol. Higher cholesterol leads to increased heart disease. Therefore, saturated fat causes heart disease. It was simple, logical, and easy to remember. If you're old enough, you can remember how this changed our world. Butter disappeared from kitchen tables. In its place, margarine and spreads made from partially hydrogenated vegetable oils, what we now know as trans fats. I still remember this shift from my own childhood. Butter was out and a tub of I can't believe it's not butter was in. That tub was filled with partially hydrogenated oil. At the same time, naturally fatty foods like whole dairy, eggs, red meat, they were demonized. They were replaced by low-fat, high-carbohydrate, heavily refined foods. This became the legacy of the diet heart hypothesis, and for decades, it shaped not just what we ate, but what we believed about health, fat, and disease. The cardiovascular carnage that followed was nothing short of disastrous. When we removed natural saturated fats like butter, lard, and tallow, we replaced them with what we thought were healthier alternatives: seed oils and partially hydrogenated oils, also called trans fats. Trans fats in particular became one of the largest insults to human health in history. It's now estimated that trans fats were responsible for up to 500,000 deaths per year worldwide. Eventually, the evidence became too overwhelming to ignore. Trans fats weren't just linked to heart disease. They were also associated with diabetes, inflammation, and cancer. They increased LDL cholesterol, reduced HDL cholesterol, and created the perfect storm for metabolic and cardiovascular disease. Finally, in 2015, the FDA moved to partially ban trans fats, and by 2018, they were fully banned in the US. But here's the part that really stings. We had known for decades that these artificial fats were dangerous, and yet it took that long. After years of delay, years of lobbying, years of industrial influence, they were finally taken off the market. It's 2025 now. Trans fats have only been off the market in the US for 7 years. In some parts of the world, they're still abundant in processed food. That's a sobering reminder of how long it can take to correct a wrong, even when the science is clear. So that brings us back to the big question. Were the conclusions of the 7-country study actually correct? Because even today, in 2025, we're still being told by the biggest heart health organizations in the world that we need to limit our saturated fat intake because saturated fat raises LDL and LDL causes heart disease. This is not fringe advice. This is coming from the top, the experts of the experts. And the foundation of this belief system was largely laid by the 7-country study. So again, Was it correct? Well, let's take a critical look. To start off, the 7-country study was plagued by selection bias and confirmation bias. Normally, when you have a hypothesis, you design a study to test whether it's true or false. Let's say your hypothesis is, if I add salt to water, it will taste like the ocean. So you add salt, you taste it, and you evaluate whether or not that's true. But bias happens when you don't try to test your idea. You just try to prove it right. You shape your study in a way that's designed to confirm what you already believe. And this happens all the time, not just in nutritional science, but across every field. A researcher who's a daily coffee drinker might gravitate towards data that shows coffee is healthy. It's human nature. When we want something to be true, we're really good at convincing ourselves that it is. And unfortunately, the 7-country study was drenched in this type of bias. For starters, the countries that Ancel Keys selected were already known from previous epidemiological data to support his hypothesis that populations with lower fat intake had lower rates of heart disease, and those with higher fat intake had higher rates. Meanwhile, countries like France, Switzerland, several in Scandinavia, which didn't fit that pattern, were left out. Why? To keep the data clean, to make the chart look good, to support a narrative that Keys had already committed to in his career and in the public light. That's not how you test a hypothesis. That's how you confirm a bias. So another major shortcoming of the 7-country study was that it was observational and epidemiological. Now, what does that mean? Well, an observational study means that researchers did not intervene. They simply observed the natural environment and recorded the data. An epidemiological study looks at large populations and tries to identify patterns. What factors correlate with certain outcomes? And very importantly here is a principle that you should not forget. Correlation does not equal causation. Let me give you an example. Let's say you notice that every time you wear sunglasses, you end up getting sunburned. You might ask, are sunglasses causing sunburn? Of course not. You're wearing sunglasses because it's sunny, and you're getting sunburned because it's sunny. The sunglasses didn't cause the burn, sun exposure did. That's correlation, not causation. And the same issue shows up in epidemiological studies like the 7-country study. Researchers observed that people who ate less fat tended to have fewer heart attacks. That is correlation, not causation. But did eating less fat actually cause fewer heart attacks? That's the question epidemiology can't answer with certainty. It can show you patterns, but not mechanisms, not cause and effect. And the study had another issue. It didn't account for other variables, very important variables. It didn't track carbohydrate intake, refined sugar consumption, or seed oil consumption, which by the mid-20th century were flooding industrial countries like the US. Meanwhile, countries with strong food traditions like Italy or Greece were still eating whole foods, natural fats, olive oil, feta cheese, anchovies. They weren't deep frying French fries in corn oil. So when we say some countries had lower rates of heart disease, was it really because they ate less saturated fat? Or was it because they weren't eating highly refined carbs and industrial seed oils? The answer is we can't know from the 7 countries data, and it is a huge confounder. But Ancel Keys took this data to the world as proof of causation, and it became the cornerstone of the diet heart hypothesis, the idea that saturated fat raises cholesterol and that cholesterol causes heart disease. This belief shaped public policy, food industry strategy, and pharmaceutical research for decades. What we really needed at the time, and what we had, but we didn't know it, were randomized controlled trials. Studies that could actually test causation, not just correlation. So what is a randomized controlled trial, also called an RCT? It's a type of study where you take a group of people and randomly assign them to do one thing or another. You don't just let them choose for themselves. You don't let them go off and do things outside of the study protocol either. This structure allows you to isolate variables, whether it's a diet, a drug, or another intervention, and really see what kind of effects it has. And back in the 1950s and 60s, these kinds of studies were more feasible. There was less regulation, looser ethical oversight, and fewer barriers to controlling participants' environments. It was during this era that 2 important randomized controlled trials were launched, both aimed at testing the diet heart hypothesis. One was the Sydney Diet Heart Study. The other was the Minnesota Coronary Experiment. Both studies were designed with a clear goal: to test whether replacing saturated fat with polyunsaturated fat would lower cholesterol, and more importantly, prevent heart attacks and save lives. Let's start with the Sydney Diet Heart Study. This trial ran from 1966 to 1973 in Australia and included 458 men. The men were randomly assigned to one of 2 diets. One group ate a high saturated fat diet, the other ate a high polyunsaturated fat diet, rich in safflower oil. When the study results were published in 1978, they reported exactly what you'd expect. Eating saturated fat raises cholesterol. Eating polyunsaturated fat lowered it. But that's where the results stopped. They didn't report anything about mortality, nothing about heart attacks, nothing about whether people actually lived longer or died sooner. And that was the question we cared about. We already knew that saturated fat raised cholesterol. We already knew that polyunsaturated fat lowered it. But does any of that actually change the risk of dying from heart disease? At the time, the Sydney Heart Study did not answer that question. Now, let's talk about the Minnesota Coronary Experiment. This was a much larger study conducted between 1968 and 1973, and Ancel Keys himself was peripherally involved in this one. It enrolled over 9,000 men and women, most of which were institutionalized in mental hospitals or nursing homes. That made it easier to control their diets precisely. Again, participants were randomized. One group received a diet high in saturated fat, and the other group had saturated fat replaced with corn oil or corn oil margarine. The study ended in 1973, but get this, the results weren't published until 1989, 16 years later. And even then, when they finally published, the focus was the same as the Sydney Diet Heart Study, stating that saturated fat raises cholesterol and polyunsaturated fat lowers it, a concept we already knew well. But the mortality data, it was only briefly mentioned and in such statistically vague language that it was hard to interpret. There were no Kaplan-Meier curves. This is the standard way to show mortality differences over time. And no real effort to tell us, did people live longer? Did they die sooner? It essentially became a massive controlled trial that didn't answer the one question we really needed to know. It wasn't until 2013, decades after these trials were conducted, that a researcher named Dr. Christopher Ramsden managed to uncover the original data from the Sydney Diet Heart Study. He published his findings in the British Medical Journal. He dug into raw data that had never been fully analyzed, and what he found was shocking. In the group that had saturated fat removed from their diet and replaced with safflower oil, all-cause mortality increased by 62%. Cardiovascular mortality went up by 70%. This completely contradicted the diet heart hypothesis, the very foundation that has shaped U.S. dietary policy, public health messaging, and pharmaceutical development for decades. This was data from the same era when Ancel Keys was promoting the 7-country study, which was an epidemiological study with known limitations. So I can imagine that Dr. Ramsden thought, if the Sydney data tells us this story, what about the bigger study, the Minnesota Coronary Experiment? He went looking. After some digging, he found the data in dusty storage, tucked away in file folders and old magnetic tapes, and he ran the numbers. And again, he found the familiar pattern. Yes, saturated fat raises cholesterol and polyunsaturated fat lowers it. We already knew this, but here's the critical part. Despite those differences in cholesterol levels, there was no reduction in all-cause mortality or coronary heart disease deaths in the group that replaced saturated fat with corn oil. And among the participants over the age of 65, the results were even more concerning. The group that had removed saturated fat from their diets had a higher risk of death. So eating less saturated fat and more polyunsaturated fat led to a higher death rate in older patients. Ramsden even analyzed the autopsy data from the study. And what did he find? There was no difference in atherosclerosis between the group that ate lots of saturated fat and the group that had replaced saturated fat with polyunsaturated fat. So no difference in plaque buildup, no evidence that replacing saturated fat with polyunsaturated fat improved arterial health. Here were 2 large randomized controlled trials designed to prove the diet heart hypothesis, and they actually refuted it. And for decades, no one saw the full picture. That is by any measure a bombshell. Because remember, the 7-country study was a weak epidemiological study, riddled with confirmation bias, and was conducted during the same era as these 2 large randomized controlled trials. And these trials, far stronger, far more rigorous studies, both refuted the core claim of the diet heart hypothesis, that saturated fat causes heart disease. So here's the question. Why wasn't this information made public? Why didn't it make headlines? And why didn't it shape public policy? It would have been a bombshell at the time, just like it is now. But here's the thing. In science, just like in politics, there's momentum. Once a big idea takes hold, once careers, reputations, funding, public policy become tied to it, challenging that idea becomes extremely risky. To swim against the current of scientific consensus, even when the data points in a different direction, it's often academic suicide. We'll probably never know exactly why the full results of these studies weren't published at the time, but it's hard not to imagine that researchers facing a tidal wave of belief in the diet heart hypothesis simply chose not to risk their careers by releasing data that told a different story. Since then, we've also had more data. One of the biggest studies to date is the PEER study, the Prospective Urban Rural Epidemiological Study. This study followed 135,000 people across 18 countries between the ages of 35 and 70. And what did it find? Higher total fat intake was associated with a 23% reduction in total mortality. Saturated fat intake was linked to a 14% lower risk of death of all causes. And perhaps the most surprising is higher saturated fat intake was linked to a 21% lower risk of stroke. Now, to be clear, the PEER study is also epidemiological. It doesn't prove cause and effect, but it's very large, it spans diverse cultures and diets, and it tells a very different story than the one we built our entire public health policy on, a policy that was based largely on the 7-country study. Another important lens we should look through is that of traditional cultures, because while in modern industrial societies we have the freedom to choose from a vast array of foods and to make conscious decisions about what we eat, traditional cultures often don't. Their diets are shaped by geography, availability, and long-standing customs, not by dietary guidelines or nutritional science. So if we can find traditional cultures with high saturated fat intake and low rates of cardiovascular disease, that gives us something worth examining. It may suggest that saturated fat, when consumed as part of a natural ancestral diet, doesn't cause heart disease. That would seem like a reasonable hypothesis to me. And in fact, there are cultures like this. The Inuit of Greenland, the Maasai of East Africa, and the Tokelauans of the South Pacific are all examples of traditional societies with very high saturated fat intake and very little heart disease. The Tokelauans in particular are fascinating. Studies of this population have shown that the Tokelauan people obtain 63% of their total calories from coconut fat, which in itself is 90% saturated fat. And yet, there was no evidence of cardiovascular disease in the Tokelauans. Let me repeat that. They consumed more than 60% of their daily calories from saturated fat, and there was no sign of heart disease. And it gets wilder. The Tokelauans are also heavy smokers. They essentially trade copra, which is dried coconut, for cigarettes. So here's the picture. The American Heart Association is telling us to limit saturated fat to less than 6% of our daily calories, much lower than any of our ancestors would have ever consumed. Meanwhile, the Tokelauans are getting nearly 10 times that amount, chain smoking daily, and they're still not having heart attacks. That's extraordinary. And I think it speaks volumes because traditional cultures aren't shaped by scientific bias. They aren't conducting randomized trials or following food pyramids. They're just surviving, thriving, as humans have done for thousands of years. Now, don't get me wrong, scientific studies are essential. They're incredibly valuable tools for understanding health and disease. But every study is still designed by a human mind, and every human mind carries bias. So if we want to observe something free from that bias, we can look to the one experiment that wasn't designed by a scientist, the experiment of human survival. The accumulated wisdom of ancestral traditions. And in the case of the Tokelauans and many others, these traditions involve a lot of saturated fat and very little heart disease. So what's the conclusion here? The diet heart hypothesis, which says that saturated fat raises cholesterol and that cholesterol causes heart disease, has been a guiding force in nutritional science for decades. But based on the evidence we reviewed, I think the takeaway is clear. Despite what we've been told, saturated fat cannot be definitively linked to cardiovascular disease. The data, real, rigorous, decade-spanning data, simply doesn't support that claim. Now, does that mean we should throw caution to the wind and start eating saturated fat in unlimited amounts? I don't think so. And that brings me to an important principle for living well, one that goes beyond just nutrition. If a little of something is good, that doesn't mean more is always better. And if something can be harmful in excess, that doesn't always mean it needs to be eliminated entirely. Balance is the key. So even though the evidence shows that saturated fat does not cause heart disease, that doesn't mean we should be spooning MCT oil into every meal or smothering everything in butter. But it does mean you don't have to fear it. You don't have to avoid it obsessively. And you don't need to follow advice that was based on flawed, decades-old science. Instead, focus on real food. Whole food, unprocessed food, food that makes sense in the context of human history and biology. Eat in a way that feels natural and sustainable, not based on fear, but based on common sense. Okay, so that was a lot, but this still leaves us with a big question. Why did the 7-country study show higher rates of cardiovascular disease in countries with higher saturated fat intake, while the Sydney Diet Heart Study and the Minnesota Coronary Experiment showed higher mortality in people who ate less saturated fat? How do we reconcile that? Is there a unifying explanation? I think there is. As it turns out, saturated fat may have been scapegoated, while a different type of fat, one that truly contributes to cardiovascular disease, flew under the radar. That's what we'll be exploring in part 2 of our cardiovascular disease series. So stay tuned. This story is far from over. And thank you truly for listening. If you haven't subscribed yet, please hit that subscribe button so you don't miss the next episode. And if you've got thoughts, questions, or feedback, leave a comment. I'd love to hear from you. I really appreciate you being here, for being open to joining me on this journey of discovery. Cheers, and I'll see you next time.